Alright, YouTube, today is the 27th of December, and I want to take a closer look at the analemma, as you see here, but not from this view. From a side view perspective, it'll be pretty much just a straight line. But what I want to try to do, and I think we could do this, is actually map out the dome. If what we're seeing is a reflection and the sun is actually not where it is compared to where we see it, there's got to be a way to figure this out. So what I've been doing is taking different cities and locations and using the timeanddate.com site to map out the locations of where the sun would be at a given time from each area. Let me show you a different view. Well, before I do that, here's a picture of the dome and what I picture. Every time we look at the moon or stars through, say, the P900 camera, it always seems like it's underwater. Not that it's underwater itself, but we might be looking at it through water. It does appear to move anyway. So taking that's what we got. This is what I actually picture the dome looking like. It's actually the dome itself. It's one piece, but it's got an open section in the middle where there's room for the sun and moon to fly around. And under here, of course, you see that's where the birds fly. It is biblical. Birds fly into heaven, and the sun and the moon are also in the dome. But anyway, let me show you another image I got here. Alright, here I got a board mapping out the sun from different locations at the same time every day, and this is for a 6-month period. It starts with Santiago, Chile. There's another city in Chile, the equator, the Dominican Republic, and ending at Boston. Now, when you look at this, it's kind of confusing and everything looks like a complete mess. And a glober would probably say, well, instead of having the flat land, if you were to put this on a globe, so in other words twist this whole thing, these lines might line up into a straight, nice, perfect curve. But we're not dealing with that, and most of us know it. So anyway, what is going on here? Why does the sun look so low? Like, say, down here in January from Boston and the Dominican Republic, the sun is really low in the sky, or it appears to be that way. I mean, this is only about, say, off the water, it's about 1,200 miles up in the air, where at the highest points where two cities would see it, it'd be almost 3,700 miles in the sky. Well, if we were to try and figure out the height of the dome, we're gonna have to try and figure out what's going on here. So I will show you that example. Hang on. Alright, this place's a mess. I got some construction going on, so you have to bear with me. These are the models I started working with. I have a curved dome. Say this is a slice of the dome that I took out. This is actually filled with water right now. Okay, anyway, I had a straight one back there, but the one that I think it would most resemble would be one like this. So I'm not even going to use that one back there, but what I will do is I will take this back section off, make it longer, and it sort of basically look like that area right in there. But here's what happens when we take a look at something. I have a socket back there. I was checking different depths. As you see, I got a battery way back there, another socket, but let's take this one for example. Alright, and what we're going to do is we'll look at it through the water here, and we'll line up the pen with this nail here pointing straight at that. So yeah, it looks pretty good. Okay, now look what happens when we go above it. So you notice where we see it is actually lower than where it really is. And I have a laser pen here. I can also demonstrate that. If you look at the wall back there, right now I got it shining through the water, and if I raise it up, you'll see it jump. See it jump to the right, probably about maybe 3-4 inches on the back wall there. Well, if this was thicker, like on this side, if it was thicker, there might be more of an angle of refraction, because right now I'm only getting maybe 6 degrees, and as you see going straight through it, it's perfectly lined up where it's supposed to be. The more angle you put on this going through water, the more it's offset. Alright, that's just one example on how the sun is not actually where we see it. Now, once I change this and make this piece straight here, I'm hoping I'll be able to get more refraction. And we'll do this one more time. I have a socket back there. This will give you an idea how much more refraction there is. Pen's pointing at it again. Okay, now that's about 10 or 12 degrees. And hopefully that would explain why the sun seems so low in the sky from Boston.